Welcome to the HiRSE Seminar Series on Research Software Engineering in Helmholtz and beyond.
Thank you very much, and I'm very flattered. I'm not sure I would call myself famous, but it's good that people know who I am. For those of you who haven't met me before, either online or in person, my name is Chue Hong. I'm the director of the Software Sustainability Institute in the UK. And also a professor of research software policy and practice at the University of Edinburgh. And in this talk, I was asked because it's the 30th talk for the HiRSE Seminar Series to kind of do a little bit of a look back at where research software engineering has come from and where it's going. And apologies to anyone who has seen this talk or elements of this talk before. It's previously been given in slightly different forms at both the UK RSE conference and the US RSE conference. But there's been a lot of change since those conferences just last year. So I'm going to be introducing a few extra things at the end just to provoke some discussion about where we might be going next in the field of research software engineering. But before I do that, I'd like to kind of go all the way back to this particular spreadsheet. So this spreadsheet is still available if you know where to look on Google Google Sheets. It is a schedule from the breakout groups at the Collaborations Workshop 2012 event, which the Software Sustainability Institute ran all those years ago, now like just over 12 years, where what we were doing was we were trying to identify different types of issues that were facing the research software community and bring people together to see what we could do to make progress on them. And as you can see, this is the session that we had on a lovely sunny Thursday afternoon. And it showed lots of different types of topics that were being discussed, including one of them, which was being led by James Hetherington, who some of you may also know as one of the famous faces of the research software engineering community, around developing the profession of a scientific software engineer. And one of the things to note here is it's not even the most popular session in this particular slot. The most popular session is using the internet and social media to increase your impact and publicize your research. So you can see that there's always been different priorities across the research software community, but I'm very glad that we did start off with this discussion. And in the bottom right, this is the one sole remaining picture that we can find that documents the fact that we were actually talking about this. So you can see the James, perhaps a blurry version of James sitting next to a blurry version of me taking some notes, and there's a lot of discussion going on. You can see that people are really intensely concentrating on this problem. So what does that mean? It means big Hamilton reference. I was there in the room where it happens. So I was there at the start of the research software engineering movement, but there's lots of different things that have come from that, and I can't pretend that that single meeting in a little room in a college in Oxford was the thing that made research software engineering suddenly the huge community that is today. There's lots of other things that have happened in the meantime. If you were to look back at the picture more closely, what you'd probably notice is that all of the people there are men, for instance. All of the people are white men. So is that representative of the community that we have now? It's probably not, but it is where it started, and I think it's useful to go back and understand the path that research software engineering has been on since that first discussion in that room in 2012. And it really was just kind of a discussion. And one of the things that came out was an understanding of perhaps where we wanted to go next. So we were asking people to put down the 5 most important things that they learnt during the discussion. And the big one that was identified was that we needed a label for a new profession. We had identified that there were lots of people who were engaged in developing software that was used in research. They were being called postdoctoral research associates, they were being called lecturers, they were being called researchers. Um, we needed a way of being able to see how many of those people existed. And that's where the term research software engineer was coined by my ex-colleague Rob Baxter. And as you can see, a lot of the other things that were being discussed are still important for us today. So things like creating an institutional professional body. So now we have things like the Society of Research Software Engineering and DERSE in Germany. We need certification. So this idea of what is the equivalent to the chartered engineer designation in the UK, or other forms of professional accreditation in other countries. We needed education and training. We needed recognition and the ability to have different types of career paths based on you progressing through a number of different projects and being able to kind of have a career that encompassed all of the different challenges to do with funding of research software engineering. So that discussion took place in 2012, kickstarted this movement, but ultimately, most of the issues that were identified there are still issues that are concerning the research software engineering community today. And it's been a very long road since then. People like James Hetherington were part of the very early aims of trying to raise awareness. So we spent a good 2 or 3 years just trying to make sure that people knew that this sort of role existed. We did things like trying to understand how many people were doing the role by looking at job adverts. We started bringing people together in the UK as parts of workshops and events to start discussing how they were being employed, what the difficulties were in their different career progression and career paths, and starting to understand the levers that we could push towards the different funding mechanisms and policy mechanisms that could help us do things to help promote research software engineering. So I've just I'm just going to kind of like, I noticed there's something in the chat. I'll look at the chat messages afterwards. So if there are any questions that you do have for later on, please do put them in the chat and we'll come to them at the end. So where do we go from here? So after the establishment of the research software engineering movement, and then the Research Software Engineering Association, and then onwards to the Research Software Engineering Society, over the last 10 years, there have been lots and lots of different successes for the research software engineering community. We now have lots of different groups across the world who have established themselves to provide centralized research software engineering services. We have research software engineers embedded in different research groups and within different disciplines. We have the conferences now in the UK, in the US, in Germany, and now also in Australasia and New Zealand as well, which are all providing us with ways of interacting, of communicating, of sharing our experiences. And there are great seminar series like this. So there's never been a better time to be able to meet your fellow research software engineers and understand what they do. However, there are still challenges. The biggest challenge is really defining what a research software engineer does to the outside world. So we are in this community where we understand each other, but there are lots and lots of different perspectives. And I think quite often one of the challenges we have is trying to understand how we show ourselves off to other people who we might be working with. So, when I talk to my friends, they all just think that I'm playing around on the computer all day. My family, who come from a very different background to me, they did medicine and geography, so they are just kind of going, this is all some sort of odd matrix stuff. To basically my collaborators, they just go like, as long as you can make it work, it's just magic to us. And to me, what I think I do is really kind of this bringing knowledge and making sure that the next generation can understand it. But in reality, if I was to look back at what I really did as a research software engineer, most of my life is just Googling for what the correct answer is. So what is a research software engineer? Why is this such an important role? Well, one thing that we can do now, because we are in the age of AI, is we can look to the world's best mansplainer, ChatGPT, to try and identify what it is that a research software engineer is for. And, it can do a pretty good job of looking at this. It's about understanding research objectives, developing software, collaboration, optimization, code review, documentation, version control, continuous learning, all of these different things that are part of what many of you will recognize from your day-to-day life. But is this actually who we are? Is it really representative of what a research software engineer does? Is it really representative of what we as a research software engineering community want to be seen to do? So where is the kind of the human in the loop here? So what does the model German RSE look like? Um, Actually, no, that's not what I meant to say. What I meant to say is, what does the modal RSE in Germany look like? So what are the most common traits of what an RSE is in Germany, at least in 2022, when the last international RSE survey was took place? So the Model German RSE has a master's in the sciences. They have approximately 5 years of experience working normally in the sciences. They chose the RSE job because they wanted freedom to choose their own working practices. They use a tool chain which you'll recognize of Linux, Python, Git, and open source. They have an ORCID. They generally have been named as a co-author. They want to improve their project management skills. They work in a team with a bus factor of 1, and they've been to an RSE conference. So is that a better representation of what a research software engineer is? Is it something that helps understand how we should be supporting research software engineers, how we should be encouraging research software engineers? I find this interesting because we've done the same analysis for research software engineers in the UK and in the US, and there are a number of differences. So one of the most striking things in the German RSE community, as compared to the US or UK RSE community, is that in general, it's about even how many RSEs have a master's or who have a PhD. Slightly more have masters. And from a personal perspective, I'm really pleased with that because I think to be a thriving RSE community, we need to be able to be inclusive of a number of different ways of becoming a research software engineer. And also because I'm someone who also only has a master's. I don't have a PhD. So it's nice to see that a PhD is not a requirement to become a research software engineer, at least in Germany. It's also really interesting to see why people become research software engineers. So from wanting freedom to choose their own working practices to wanting to remain connected to the research environment without having to go through the rigors of promotion only through publication. There are lots of things that point towards why the research software engineering profession is something that people are interested in. Um, the one challenge, I guess, is that bus factor one. So that is definitely something where, for those of you who don't know what bus factor means, bus factor is the number of people in a team who you'd have to lose before it was impossible to do the work of that team. So that's suggesting that if any one particular research software engineer was unable to work, then the things that they were working on would not be able to progress. And that's actually a little bit lower than some of the other countries where the bus factor is closer to 1.5. But it is still better than some of the groups that we've talked to, where they've noted that their bus factor is actually such that it's going in the other direction. If they lose one person, then 4 projects are affected and can't work. So it's really interesting to see this sort of information. It can be quite useful to understand broadly what the average research software engineer is, but does it tell us any more about what a research software engineer is or does? So this is a slide that is probably the thing that most people outside of our community and many people inside our community would associate with research software. It's probably the most famous scientific image of the last 10 years, and it's probably the most famous example of the use of software that has got into the general public. So the question here is Dr. Katie Bowman, is she a research software engineer? And I guess the question here is, do we need to ask that? Can we not just kind of identify that perhaps she's been doing research software engineering? Perhaps she's only been a researcher who's been developing software. Perhaps it's something where she has made the decision that she wants to be called a researcher rather than anything else. I think the point here is that we've got to the stage now where, in the discussion with the wider scientific, research, and public community, we're starting to split this idea of research software engineering from research software engineers, from the engineering of research software. Um, and much like Monty Python's sketches, there's often a lot of different challenges when you start confusing people from the difference between software engineering research, for instance, and research software engineering. So perhaps what we should be doing is we should be kind of, instead of trying to make everything look the same, to celebrate the differences in our community. And so, with apologies to my colleague Simon Hetrick, who really is one of the people who should be celebrated as the parent of research software engineering, as one of the people who did so much of the work at the start of the research software engineering movement, and who's still doing a lot in this area today. I'm going to take one of his classic diagrams, his figure, to show where the research software engineer is, and see where it's got to 10 years on. So here is how he was describing the research software engineer when we were trying to get recognition for this around about 2014. So there was this idea that there was a continuum that went between doing software engineering and doing research, where you had people like you had some researchers who were also developing software, but who wouldn't call themselves a software engineer. So they were probably a little bit closer to the research side of the spectrum. And there were people who called themselves software engineers, but didn't really involve themselves in doing any research. So here was this thing called the research software engineer that sat in between software engineering and research, and had an equal foot in both camps. So the idea here is that they had a knowledge of the research, but that they didn't want to be judged in the same way as a researcher, and they had an understanding of the software engineering, but they weren't being used as someone who was basically a contract service with no knowledge of how the research worked. And that's a really good way of looking at things until you start realizing that there are many more dimensions than just software engineering and research. There's where the research software engineer is located. So we've discovered that there are a whole number of different ways of doing this, from having centralized teams perhaps based at a university, to having embedded research software engineers within a research group and everything in between. At my own university, for instance, there is no central team. There are many different types of central team. Some of them are looking at supplying research software engineers to sets of departments like politics and economics. Others are centralized in a department like the one I sit in, EPCC, where we have around about 120 research software engineers, but we don't work just within the university. And sometimes we embed our research software engineers within a larger consortium, and sometimes they're working as a service to a commercial project. Uh, you have all sorts of different types of software engineering expertise being brought by research software engineers. It's not just the case that it's RSEs working in modeling and simulation or data science. We also have RSEs who are looking more towards the hardware, operating in a DevOps or ResOps role. And you have people who are looking at the development of applications or web apps or mobile apps. So we have such a wide breadth of different roles from a software engineering perspective that can be applied here. And then obviously we have a much larger diversity of the fields in which research software engineers operate in. It used to be the case that most research software engineers could be found in the physical sciences, particularly in physics and chemistry, but now we see them in all sorts of fields, from things like the creative arts to law to divinity to social sciences. So I think what I'm saying here is that research software engineers are complicated because they can be many different things to many different people. But ultimately, there's still that kind of key aspect, which is around managing to make that bridge between the understanding of how to create high quality software and the understanding of how to translate research and the carrying out of research into a form that can be done using computers and computational infrastructure. And so that's where we are today. We are a community bringing together lots of different types of research software engineer so that anyone that you might be standing next to at any particular research software engineering conference may look very different from you, may have a very different background, may be working in very different areas, but ultimately you still share something with them in terms of the outlook that you have on how you do things and the reasons why you might want to be a research software engineer. So these are the different people. The people on this call are all different forms of research software engineer, and there's plenty of experience that can be shared, skills to be learned, knowledge to be exchanged. So then, where are we kind of going next? Well, one thing we're starting to do is we're starting to make those differences much more evident. So one example of this is through different types of podcasts. So Vanessa Sochat has a podcast called Developer Stories, which interviews research software engineers, but also a wide range of other types of developer who are operating broadly within the space adjacent to research. And I think one of the great things about that podcast is understanding all of the different ways in which people go about their daily work. And there's a lot to be learned from the different types of tools they use, the processes, and their approaches. And likewise, Peter Schmidt produces the Code for Thought podcast in both English and in German, where he interviews people on a range of different topics around research software, from research software engineering topics. He helps produce a series called Bite-Sized RSE for the Software Sustainability Institute, which looks at specific different topics that you want to kind of learn very quickly. But he also does interviews with a number of the different people who are working within this area to kind of, again, find out how people go about their job, how they got into their career, and where they think the whole RSE community is moving next. So as our profession is maturing, um, one of the big things that we need to address is the idea of sustainability. And I say this coming from the the Software Sustainability Institute. And one of the things that we've had to contend with for almost 15 years is no one really knowing what sustainability means. So, sustainability can be defined in terms of different things: environmental sustainability, sustainability of form, sustainability of practice, endurance. It is a word that is very hard to pin down to one specific definition, much as research software engineer and research software engineering is a phrase that is hard to pin down to one particular definition. But I do think that we can go a bit further to understanding where we should be going now that we have organized ourselves into a community. Um, and so, one of the things that I have been doing in my role, looking at policy around research software, and in particular working with an organization called the Research Software Alliance, who is responsible for bringing together different research funders who have an interest in funding research software to identify the best ways of funding research software sustainably. And so one of the questions is, what does it mean to fund research software sustainably? And we can look to other places for this. So one place we can look to is we can look to something called the Three Ts framework, which was developed by the OECD to help understand the sources of funding for a resource which is even more important to sustain than research software, and that is access to water. And the three T's are basically this definition of things called tariffs, taxes, and transfers. And they set in place the way in which the way in which we should be funding the access to water for humanity. And so there's this idea that there are tariffs. Those are the fees paid by users of the service, the users of a water service. Taxes, which are the subsidies from taxpayers to help supply the service. And transfers, that is where perhaps one country helps another country because it is in everyone's it benefits everyone for that sort of transfer to happen. Um, Another thing that we can look at is the work that's been done by the UN General Assembly in trying to understand how we do development more generally in a sustainable way. And they've come up with this idea of 17 different sustainable development goals as a sort of shared blueprint for how we ensure that the people and the planet are successful and thrive now and in the future. So this is again emphasizing the interconnectedness of all of the different things that we do. The fact that you can't just do one piece of development separately from another, in the same way that you can't treat the water system as being somehow disconnected and respecting country boundaries. Um, Whenever we look at this, and whenever we look at anything that appears to be limited to one country, it's almost always because it is constrained by either legal or by financial and funding constraints. And these are, in some sense, arbitrary. They are things that a country has placed there because they want to control something, rather than it because it is the right thing to do for the world. So what we've been trying to do is understand, what does this mean for research software development and research software engineers? Can we identify things that are generally good for all research software engineers to be doing when they're developing research software? And so been coming up with this idea of research software development principles as part of the work I've been doing at the SSI. And as I mentioned, the reason I think that these are important is that there are lots of different facets to the sustainable development of research software. When we first started as the SSI, we often got confused by people who thought we were about environmental sustainability, when the way that we had defined sustainability was about software being able to be used in the future. So it's sustaining the form and the maintenance of software. However, now, as we're going into the fourth phase of the SSI, we have put environmental sustainability as one of the new pillars of what we are doing, because again, it's something that we can't look at separate from the other forms of sustainability. Um, We've also noticed that it can't be something that is done by individuals, by a single organization acting on its own. Um, we can't do it just as a Software Sustainability Institute. We have to work with others to be able to sustainably develop research software. Um, so the question that we were posing to people as we were drafting these is, how can we make research software development better for all? And so um, I've come up with these 9 different principles, organized into 3 groups of 3 based around who they most benefit. And so the first set are around 3 principles that help benefit your team, so the people that you're working with. One of them is around FAIR, so being findable, accessible, interoperable, and reusable to ensure that you get as many users of your work as possible, which helps out your team indirectly by ensuring that there's always good feedback, always the higher probability of funding, and always the chance of more people being involved in contributing to your software. It's about being secure, so being able to respect data privacy when you design software, and also make the assumption that it's not a case of whether someone will try and create a cyber attack on your software, but to assume that it will happen, and to ensure that your software and your processes around the maintenance and response to any attacks are sound. And it's about being maintainable. So making sure that your software is easy to adapt and it's easy to correct any of the faults that might happen as you go forward. The second set of 3 principles are about helping your peers. So this is about making sure that other research software engineers benefit from the way that you do things. So one is to make sure that your software is reproducible. That's because doing so helps enable trust in research, and it helps both researchers to feel that it's a benefit to having a research software engineer in a team or a consortia, but also to the general public to make sure that research is not seen as being somehow flawed or untrustworthy just because they may have been a mistake in the software. Um, it's about making sure that you recognize all of the different roles that are participating in research software development. So as a research software engineer, you should make sure that you celebrate your fellow research software engineers, but also that you recognize the different roles that may not be called research software engineer that help out. So project management, people who are technical writers, all of the different roles that are required to sustainably develop research software. And it's also about developing the next generation. So you should recognize and celebrate when people are achieving things to do with research software, rather than what is often the case in traditional academic environments, where there is a fear that if you do not take credit early enough, that you will not be promoted. And it's being inclusive as well. One of the things that we're noticing, for instance, in the UK, is that while we have many vacancies and requirements for more research software engineers, we're starting to see the number of people applying dropping down, mostly because we've always looked to a particular subset of all researchers to draw this pipeline of research software engineers. So traditionally, always from physics. And so, if we're not inclusive of a much wider set of different types of people, for instance, people who don't have PhDs, people who come from outside of the sciences. We're not going to be able to have the diversity of research software engineers to solve the problems and to develop and sustainably maintain the software that we'll need in the future. And then finally, there's three other things, three principles which are about helping the world that we live in. So one is about being responsible as software developers. It's about making sure that we understand our impact on our environment in the many different ways that this can happen, from energy usage to the usage of different types of raw resources, to even understanding what this means for the way that people use the software. It's about being open and global. So I mentioned that many of the things that seek to prevent sustainable development are really artificial boundaries placed because of funding or legislation. So being able to understand how to collaborate globally and in an open way is incredibly important. And then the last one, which is even more important now than it was 15 years ago and 30 years ago, is to make sure that we follow the principle of being humanist. So basically, making sure that what we're doing is in support of humanity, making sure that our software is unbiased, is ethical, and particularly now that we are seeing the rise of AI, being transparent in understanding why it has been created and why decisions are being made. So those 9 principles are what I call the research software development principles. They are free to be reused, and I hope you find them useful as a way of helping to structure the way that research software engineering could and should be done. Um, I'm always happy to engage in discussion about some of these because I don't think they're necessarily quite correct yet. But I would be interested to hear how you find using them, whether there are any that you find harder to use or harder to describe to other people, or whether you think there are things that are missing from this. But I promised you one last thing before I finish, which was to kind of see what's changed since this presentation was given at US RSECon and UK RSECon. And the one big thing that has changed is around looking to the future of research software engineering, particularly in terms of where we're going with code assistance and also where we're going with funding. So you cannot help but notice the rise in the use of code assistants such as GitHub's Copilot. And one of the things that's become really interesting, even in the last year, is that it has gone from a few people, a few researchers trying them out, to a large minority of researchers using them on a week to week basis, where what we have is researchers writing exploratory code with the assistance of GitHub's Copilot. So, what does that mean for what the research software engineering profession is? We've spent the last 10 years persuading researchers that it's important for them to work with research software engineers to make sure that their code can be written in a way that is reproducible, of high quality, and so on. But we are expensive. You know, research software engineers are another person. If you can get this for low cost through AI, will we see the same thing happening where research groups turn away from employing research software engineers and instead using that money to hire another researcher who can use a code assistant? So I think we need to examine where the role of RSEs will shift as basically different ways of developing research software become more commonplace. I think the kind of key thing here is understanding what's the role of RSEs in helping to verify the software, to help the researcher understand whether it is doing what they expect it to do and it's modeling the phenomena that they want it to, as well as how research software engineers will have a role to play in maintaining software that may have had AI assistant input. And that kind of leads on to the second thing that's open for discussion, which is who should pay for research software engineering effort. Um, there are lots of different stakeholders in this. There's the researchers who use research software in their work. There are the research they're the research organizations like universities and laboratories that they're based in. They are the research funders. There is industry, and there's the broader society. But it is a real issue because at present, really, there are only two um, there are only two of these stakeholders that are supporting research software and research software sustainability: the research funders and the researchers themselves through voluntary efforts. So I think if we are to understand how to do research software sustainably, we need to understand how we share the burden for paying for research software engineering effort. Okay, I'm going to stop. I'm going to stop now. I have a huge amount of thanks to give to my SSI teammates, as well as a whole set of other people who have helped contribute to the ideas in this talk. But with that, what I'm going to do is I'm going to kind of stop sharing my screen, and I'm happy to take questions.
Thank you for watching our seminar. Please check out the slides on Zenodo linked below and see you next time.